When did you last see recycling machines or centers in your area? How many plastic bottles, cartons, glass bottles, and papers have you thrown into the trash in the past year? In fact, according to the OECD in 2019, the United States generated around 500 pounds of plastic waste per person annually, with only 4% of the total waste being recycled. Hi, my name is Amit Aharoni. I'm a computer science student and a former student of LSUE. I have worked with Professor James Jean on developing a green blockchain token. The aim was to create an environmentally friendly digital currency that can be earned by participating in recycling programs. Participants receive digital credits for each bottle they recycle. These credits can then be exchanged for goods and services exclusively at small and local businesses. At the end of this presentation, I will demo a person depositing bottles at a recycling machine, receiving digital cash in return, and using these digital tokens at a local store. And finally, the store can either use these tokens to buy other goods or redeem them for real cash. The whole of this system is implemented using secure blockchain technology. Today, we'll discuss the project's technology, the positive environmental and economic effects, and demo the system. What is blockchain? Blockchain is a distributed digital ledger that securely records transactions across a network of computers. Think of it as a public notebook where each entry gets added to a chain of previous entries. Once an entry is added, altering the system is very difficult, making it secure and trustworthy. This technology is the backbone of digital currencies like Bitcoin and can be used for many other applications. How does it work? A user submits a transaction, for example, transferring coins from one wallet to another. A number of transactions are collected into one block. A block is a collection of transactions. The network validators agree to accept the block and add it as a new block to the chain of blocks. One of the validators gets to add the block in a way that all the other validators agree. All blocks in the chain, from the genesis, the first, block to the last block added, are immutable, meaning they cannot be altered. The blocks are linked and depend on each other. So if someone attempts to change a transaction in one of the blocks, they need to change all the blocks. The immutability is achieved because this change is very difficult. Essentially, the blockchain provides a single source of truth, and everyone using it can trust the information stored on it. All the entities using the blockchain know that none of the other entities can cheat the system and change the data on the blockchain. The result is a distributed trust. Bitcoin was the first blockchain and the first crypto coin. Ethereum came next. Ethereum introduced the concept of smart contracts, which, honestly, between me and you, and don't tell anyone, they're not smart and they're not contracts. They're applications running in a very secure environment. Bitcoin serves only fund transfers, while Ethereum offers the ability to implement a wide range of applications. The most common programming language for developing smart contracts, of which I have used in this project, is an object-oriented programming language called Solidity. Ethereum offers a mechanism called ERC20, making it easy to develop tokens representing digital cash. The original consensus protocol presented by Bitcoin was named Proof of Work. This agreement protocol determines how the validators, in Bitcoin they are called miners, add new blocks to the chain. Since the publication of the Bitcoin white paper, many other agreement protocols have been developed. The one used by Ethereum today is called Proof of Stake. Proof of Work requires significant computational power to solve a complex mathematical puzzle. The first validator, miner, that solves the puzzle gets to add the new block. Proof of Stake is a consensus protocol where validators are chosen to create a new block based on the number of coins they hold and are willing to stake or lock up as a collateral. This method significantly reduces energy consumption compared to proof of work. Since this project intends to help the environment, choosing the Ethereum proof of stake was a natural choice. There's a vast difference in energy consumption between the two consensus protocols. Proof of work's high computational effort translates to high electricity consumption, contributing to carbon emissions and other environmental issues. As of a data point in 2021, Bitcoin's annual energy consumption was 130 terawatts hours, comparable to the entire electricity consumption of Argentina. Proof of stake Ethereum network consumes around 0.0026 terawatts per hour per year, which is about 53 times lower than the energy consumption of the proof of work Bitcoin's network. Other than the technological advantages, this project encourages people to participate in recycling programs, bottles, papers, glass, etc., by exchanging recyclable material for digital cash tokens. Incentivizing recycling programs reduces waste, promotes good recycling behavior, and decreases landfills. Other than the environmental positive effect, it also supports local businesses by directing recyclers to spend their tokens at local vendors. Now, for the part you've all been waiting for, let's demo. In the process of developing the system, I was focused on building the core blockchain application. I did not spend time on the user interface, so I will use tools to show the state of the blockchain for each activity. I will use a block explorer. A block explorer lets you view and search the transactions and other blockchain activities. I will be using Etherscan, which allows me to activate the contracts and then show the new state of the blockchain. These are the four main components of the system. The recycler can earn tokens and spend tokens. The shop can receive tokens, transfer them, and redeem them. Machine can mint and burn tokens, meaning it can create and then burn the token. It can approve the bottle's deposition from the recycler and can approve the token's redemption from the shop. And last but not least, the municipality, which can assign roles and assign other municipalities in order to expand the project. This is the data flow of the system. First, the token was created. Genesis Municipality, the first municipality, assigns shops, machines, and other municipalities. Then we divide the two main parts. Recycler. The recycler registers. He can deposit bottles and receive EcoCoin tokens. In the meantime, the shop requests to register. The municipality approves the shop. And then the recycler can spend the tokens at the shop. And at last, the shop can redeem the tokens. Now, let's go for the actual system. I have created an environment that already has two users registered, myself and Professor G, two municipalities, Eunice and Lafayette, two shops, Cafe Mosaic and Coffee Dash, and two recycling machines. One of the users, Professor Jean, will deposit 25 bottles in one of the recycling machines, receive 50 tokens, and use them to buy coffee at Coffee Dash. Coffee Dash can use these tokens to buy goods, but in this demo, we will have Coffee Dash redeem the tokens into US dollars at the recycling machine. Now, let's deposit the bottles. We are connected with Mr. Jean's account. We're on the machine contract. We have entered the machine ID, the number of bottles, and now let's write the command. Confirming the transaction, and in just a matter of few seconds, we can see the transaction is approved. And success! We have successfully deposited 25 bottles into Mr. Jean's account. And we can indeed see that in Mr. Jean's account, in his wallet, we have 50 EcoCoin deposited successfully. Now, once again, we're still connected with Professor Jean's wallet, and we want to spend our goods. We want to buy coffee at Coffee Dash. So we're entering the shop ID, the spending amount, 5 tokens, $5. Proving the transaction. The transaction is confirmed, and we can go to Coffee Dash's wallet and see he has now 5 EcoCoins. Great. Then Professor Jean deposited 25 bottles, received 50 tokens. He bought coffee at Coffee Dash, and now Coffee Dash can redeem the tokens for US dollars. We're back at the machine contract. We've entered the machine ID we would like to redeem the tokens with. We've entered our Cash App username, the amount of tokens we wish to redeem. We then approve the transaction. And again, within a matter of seconds, we can see the transaction will be approved. And we can see our tokens from our wallet will be gone. We can see the transaction was a success, and Coffee Dash no longer has tokens. The tokens were burned, means no one got them. And now our process is complete, and our demo is complete as well. In this project, I created a special EcoCoin that encourages recycling and boosts local business, implemented on a secure blockchain platform. Thank you very much for listening.